Hello there, Algebra 1. Today in class we went over section 6.1, which are all about our exponent rules. So today we're going to take a peek at these again, and then we're going to do a few practice problems with them. So one of the things we talked about, of course, is anything to the 0 power. Anything to the 0 power, and as we discovered today, is 1. That one exception is 0. 0 to the 0 power is undefined. So when we have this, we literally can take anything. So we could do 64 to the 0 power. That's equal to 1. 792 to the 0 power, still 1. Negative 973 to the 0 power is equal to 1. Anything raised to the power of 0 is 1. The next thing we talked about were our negative exponents. And negative exponents don't mean the negative number. It actually means a smaller number. Or, as we would call it, negative exponents means movement. And we move either from the numerator to the denominator or from the denominator to the numerator. So something like 7 to the power of negative 2, this turns into, we go ahead and we actually move it down to the denominator. So whenever we have negative exponents, I like to kind of draw our fraction bar line. We're going to move it to the denominator and make the exponent positive. And then that makes our numerator 1. Now, sometimes it's in the denominator already. So 1 over 8 to the negative 4. And again, this means movement because it's a negative exponent. So this becomes, I'm going to go ahead and draw that fraction bar line. I'm going to move it to the numerator, so 8 over 4, and then I'm left with 1 in my denominator. We just write that as 8 over 4 because anything over 1, we go ahead and take away that over 1. Now, here's a bit of a challenge for you. And I want to show you that sometimes things move, and however, if you have positive exponents, they're going to stay. So we can have something like a to the power of negative 2 is equal to, a to the power of negative 2 times b to the power of 4. Now, a to the negative 2, this one is the only one with a negative exponent. So when we simplify this, we're going to draw that fraction bar line, and a to the second moves down to the denominator. However, b to the fourth is a positive exponent, so we keep it in the numerator. I'm just going to add a little note here. We're going to say keep because it's a positive exponent. All right, so you keep anything when it's positive exponents, you don't move it, you move only your negative exponents. Another rule that we worked with today, we're multiplying with the same base. And when you multiply with the same base, you're going to go ahead, you're going to take your exponents, and we're going to add our exponents. I'm going to give you a little way to remember that in just a second. You're going to multiply same base, add your exponents, and we called this today our product property. Product of a power property for the official name. So we might have something like 7 to the power of 2 times 7 to the power of 4 times 7 to the power of 3. Okay, all of these have a base of 7. So we have base of 7, base of 7, base of 7. All right, then we're going to go ahead, we're going to take those exponents and add them together. So keep our base. Keep the base that is right there. then we're going to take 2 plus 4 plus 3, which makes this 7 to the power of 9. 2 plus 4 is 6, plus 3 is 9. And this works with letters too. So we could have, or sorry, I should say variables, a to the power of 8 times a to the power of -3 times a to the 5th. So same bases, a, and a. We're going to go ahead and keep the base that we have, and then we're going to add our exponents. So 8 plus -3 plus 5. So 8 plus -3 is 5, plus 5 is 10. So this equals a to the power of 10. We had kind of the same thing, but now we're dividing. So dividing with the same base, but instead of multiplying your exponents, you now subtract exponents. Has to be same base though. Must be same base. So we might have something like 8 to the 9th over 8 to the 4th. That would give us 8 to the power of 9 minus 4. So when we go ahead and take 9 minus 4, we get 8 to the power of 5. And again, with your negative exponents, it works exactly the same way. So I could have x to the 4th over x to the -6. So you can still go ahead, same base, x and x. We can go ahead and we can take x to the power of 4 minus -6. Now 4 minus -6 turns into plus plus. So this final answer is x to the power of 10. Now, the way that I go ahead and I remember this is that I think of PEMDAS written in this special way, and it's been a while since we've written it like this, PEMDAS. And so when I think about multiplying, if I'm multiplying same base, I'm going to add my exponents. Now, if I divide by same base, I'm going to go ahead and subtract my exponents. So I always think of it kind of one step down on PEMDAS, which leads us to that last rule that we had today, which is that if you have exponents to an exponents, you end up multiplying your exponents. So this is power to a power, and you end up multiplying the exponents. So for examples on this, we could have 5 to the power of 3 all to the power of 8. So you go ahead and this ends up being 5 to the power of 3 times 8, which is 5 to the power of 24. And same things on your variables. So a to the power of 6 all to the power of 2 means a to the power of 6 times 2. That means a to the power of 12. And so for your challenge on this one, we're going to have b to the power of 7 to the power of -3. So when I multiply these, I get b to the power of -21, and I can't keep it like that because I have a negative exponent. But if I scroll up here a little bit, I know that exponents mean movement, so all I need to do is take this and move it down to the denominator, b to the 21, and then write my numerator as 1, and that's the final answer for that one. Okay, I have 3 problems for you. I would love if you go ahead and pause the video once you write it down, try it yourself. You can always go back and fix it. So we're going to start with 15 to the power of -1, x to the power of 3rd, all over y to the -5th. Okay, so we need to go ahead, we need to simplify it. First things that I like to see is that if any of these bases are the same. So 15 is a base, x is a base, and y is a base. None of those are the same, so I can't combine anything. My next step is that I need to go ahead and move exponents that are negative. All right, I'm looking for my positive exponents first. So x to the third is positive, meaning I'm going to keep it up in my numerator. So there's x to the third. Now, I'm going to go ahead, I'm going to move any negative exponents. So I'm going to move y to the fifth up to the numerator, make it positive, and I'm going to put 15. Now I could say to the positive first, but I don't have to because 15 to the first is just 15. I'm going to double check to see if I can combine any bases. I can't, so this right here is my final answer. All right, let's work with example 2 here. I'm going to have 2 times x to the fifth, y to the sixth, all to the power of 3. Now, we want to go ahead, we want to simplify this, and there's something sneaky here, which is that 2 has an exponent of 1. So you need to make sure that you're applying this 3 to every exponent in here, and you're going to multiply every single one. So this ends up being 2 to the power of 3, x to the power of 5 times 3, and y to the power of 6 times 3. Now, I can go ahead and I can say x to the power of 15, y to the power of 18. Now I can actually solve this 2 to the power of 3. 2 to the power of 3 is 2 times 2 times 2, which is 8, meaning that this final answer is 8 times x to the power of 15, y to the power of 18. Okay, your very last one, example 3. We're going to, it's going to be numerator, denominator, x to the power of 3, x to the power of 4, all over x to the power of 6. So they have the same bases here. X, x, and x are all the same base, meaning that we need to go ahead, we need to combine them. Now, I like to work with my numerator first. And in my numerator, we can go ahead, they're multiplying together, and if they're multiplying together, we're going to add our exponents. So this becomes x to the power of 7, and I didn't touch the bottom one. Okay, now they're same base, and we're dividing them. So we're going to take this as x to the power of 7 minus 6. That's x to the power of 1. We just leave that as x. All that work there, final answer is x.